section 12-5 is about equations of circles in the coordinate plane, which is especially important to those of you going on to Algebra 2 next year or Algebra 2 in the future. Okay, now to get the equation for a circle in the coordinate plane, I want to think about a circle as all the points that are the same distance away from some center point, and that distance is the radius r. Okay, now I'm going to draw in kind of the coordinates, that the lines that make up the coordinates of this point that I'm rotating around. Okay, so I've drawn in here x and y, and those are going around the circle. Now, what you'll notice is that because x is always on the x-axis and y is always parallel to the y-axis, this triangle is always a right triangle. Okay, so I can use the variables x, y, and r and the Pythagorean theorem to come up with the equation of x squared plus y squared is equal to r squared. So no matter where the circle is, x squared plus y squared will be equal to r squared. Okay, now that's really easy to see if our center happens to be at the origin, but it's not always at the origin. So let's look at what happens if the circle is not centered at the origin. Okay, I have moved the circle to some center that I'm going to call h comma k, where the x coordinate of that center is h and the y coordinate of that center is k. Now it's still true if I rotate this around that it still makes a right triangle. Okay, but the trick is how long is this length? Okay, it'll be x minus h. Okay, because x is the distance from the origin to that point, and h is the distance from the origin to the center, and so this is x minus h. This right here is y minus k. Okay, and the radius is still going to be the radius. So again, using x minus h and y minus k, I can still plug those into the Pythagorean theorem and get the formula of x minus h squared plus y minus k squared is equal to r squared. Okay, and that is our formula for the equation of a circle, and we call this in standard form. All right, so here it is from the textbook, x minus h squared plus y minus k squared, and that's equal to r squared. Okay, now I hope this reminds you of the Pythagorean theorem, because it should. It also can remind you of the distance formula, because those ideas are all come from the same foundation of the Pythagorean theorem. Now let's use this in several different ways to show you how this formula, this equation, can be used. Okay, what is the standard equation of the circle with center at 5, -2, and radius 7? Okay, well the formula we'll keep coming back to, x minus h squared plus y minus k squared is equal to r squared. Okay, the center is hk. So 5 is h, and k is -2. So x minus 5 squared plus y, let's see here, minus k, but k is -2. So if I subtract a -2, it's y minus a -2 squared is equal to, the radius is 7. Now it's 7 squared. It's a very common mistake that students forget this to square the radius. Okay, so this is the equation of our circle, and you can leave it like this, or you can multiply 7 squared and get 49, but I would take this as a correct answer. Okay, next question. What is the standard equation of the circle with center 1, -3, again this is h and k, that passes through the point 2, 2? Okay, now they didn't give us a radius, but we can use this information to find the radius. Okay, again the formula is x minus h squared plus y minus k squared is equal to r squared. I'm going to plug in this for h and k. I'll do these separate just so it's super clear. Now y minus a -3. Now the y isn't always negative, that just happened in these past two questions. is equal to r squared. Now I'm going to plug in this in for x and y so I can find r. So 2 minus 1 squared plus 2 plus 3 squared is equal to r squared. Now, inside the parentheses, 2 minus 1 is 1. 2 plus 3 is 5. That's equal to r squared. So 1 plus 25 is equal to r squared. And r squared is equal to 26. Now, we could write that r is equal to the square root of 26, but since we're plugging it back into our formula that has r squared, I'm just going to leave it as r squared. Okay, so now I have all the pieces that I need. I'll plug it back in with using this part, x minus 1 squared plus y plus 3 squared is equal to 26. And this would be the equation that would have a center at 1, negative 3, would go through the point 2, 2, and have a radius of the square root of 26. Next question. Find the center and radius of each circle and graph the circle. So I'm going the other way. I'm taking the equation and I'm finding the center and the radius, and then I'm squaring it. I'm sorry, then I'm graphing it. So in this case, the formula is x minus h squared plus y minus k squared is equal to r squared. Don't forget the fact that it's r squared. Okay, that means that the center hk the h must be 8. Okay, now in this formula there is no y minus some number, so that means that k would have to be 0. Okay, so it's the center of our circle is at 8, 0. So 1, 2, 3, 4, 5, 6, 7, 8. This is the center of our circle right here. Okay, now the radius of our circle is not 9. Okay, because what we found is r squared. So if r squared is 9, what number squared is equal to 9? Well, r would have to be the square root of 9 or 3. So I'll just kind of go over this way 3. I'm off the graph a little bit. Over this way 3. I go up 3. I go down 3. I kind of just sketch a circle that would go through those 4 points. Okay, and that's the circle. Okay, number 2. Again, the formula is x minus h squared plus y minus k squared is equal to r squared. Now, in this problem, it's going to be x plus 2, which means h must be equal to a negative 2. So that x minus a negative 2 would become x plus 2. So you always change the sign for h and k. In this case, k would be equal to a positive 4 because it's y minus k and it's y minus 4. So k is a positive 4. Again, you kind of switch the signs. And the radius is the square root of whatever number I'm given there. Square root of 7. Okay, so let me plot the center. I'll draw the center as negative 2, 4. The center is negative 2, 4. 1, 2, 3, 4. It's right here. And the radius is the square root of 7, which is between 2 and 3. So somewhere between 2 and 3. You can find the decimal if you want. But somewhere like this. I'm just kind of sketching the graph. It's like that. Okay, finding this center and radius, and then graphing the circle. Okay, so the last question we're doing together is to write the standard equation of a circle, where I'm given a picture of the center and the radius. Okay, this center looks to be about 2, 2. And the radius, I'm going to assume that it is what it looks like it is. It's about 1, 2, 3, 4. I'll just say the radius is 4. Okay, so the equation of our circle would be x minus h squared plus y minus k squared is equal to r squared. So plugging in those numbers, x minus 2 squared plus y minus 2 squared is equal to the radius squared, or 4 squared. And I'll take this as the equation in standard form of this circle. Okay, so everything in this section kind of revolved around this formula of x minus h squared plus y minus k squared equals r squared, where the center of the circle is at h. Okay,